This is a noughts and crosses game. It's driven by a Pi Zero and demonstrates the principles of how to read a grid of reed switches and signal positions using LEDs, as well as put messages on a simple LCD. So when we switch the thing on, it starts by asking us whether we want to play at this level. The LCD says level equals expert, yes or no. At expert level it will always beat us, so we'll place no, and it cycles through the different levels, which are idiot at the lowest level, good at the next level, or expert. So we'll agree to expert. It then asks if we want to go first, yes to go first, any other, and it goes. So I press no and the machine will go. It says me to go first, making my first move, so put an X on its move. It then invites us to make our move, so we're going to put an O there. It's now say it's going to make its move, which is X there, and inviting me to make my move. I'm going to make a deliberately bad move in order to end the game, so I'm going to go here, giving it the opportunity of completing a diagonal crosses, which it does by making its move there, and then it declares that it's won and flashes the game ready for the next game. Starts off by saying please clear the board. So we clear the board. The playing pieces are Scrabble pieces, which you can buy cheaply on the internet, with magnets on the back. I'm taking off the lid and turning it over. And we can see in there the various components. So we've turned it over, and I'll explain all the components in detail, but in summary what we have is the grid at the top, which contains reed switches and LEDs all wired up. The LEDs are connected to this component on the breadboard, which is an LED controller. The reed switches are connected to this element, which is a port expander, and then we have this LCD with built-in keypad, and finally the Pi Zero, which is driving the whole thing. So let's have a look at that all in a bit more detail. The reason for designing the noughts and crosses game in this rather complicated way is to act as a training or pilot scheme for building the electronic chessboard, which is also described on the site chess.fortherapy.co.uk. The chessboard uses exactly the same components, only instead of having to wire not just 9 squares, you've got to wire 64, which takes a great deal more time. So if you can build this noughts and crosses system, then you have all the skills you need to build a sensory chess system that can have a chess engine built into it running on the Pi, which plays at the level of a grandmaster. This schematic shows how the system works. You can see first of all that it uses I2C to communicate between the various components. The main component is the Raspberry Pi. It can be any Pi, but in this case a Pi Zero, which acts as the master for the I2C system. The first component that is connected is the MCP23017, which is a port expander which is connected directly to the reed switches. The next component is a LED matrix driver, which again therefore is connected to the LEDs. And finally we have an LCD screen with a built-in keyboard, which is also connected. And the beauty of having all of these connected to the I2C ports is that there are only 4 connections to make to the Raspberry Pi. So let's see what this looks like in physical terms. So first of all we start with the front board, and this is the back of the front board, so to speak, to which all the pieces are going to be stuck. The first group of pieces we stick on are the two components. At the top left hand corner you can see the matrix controller, and next to that the thin black port expander. In this part of the system, the matrix controller, the LED matrix controller, is connected by those various wires to all the LEDs, and you can see I've shown how the LED cathode is put in pointing upwards and the anode right, so that therefore the wire C2 can connect all the cathodes, which are vertical, and then the wire C2 goes on and connects to the cathode connection on the LED matrix controller. Similarly, all the anodes, A0, 1 and 2 sides, are connected to the anode side of the LED controller. So relatively straightforward wiring there. The next thing we look at is wiring the port expander, which connects directly to the reed switches, which are not wired as a matrix but are wired directly. So each reed switch is connected to one port on the port expander. This shows first of all the earth wire. So the reed switches can be wired any way round, and the first thing we do here is glue them to the matrix. Notice they're situated off center, about halfway down the quarter diagonal opposite the LED. And this shows how the earth wire, the green one, zigzags between them to connect them all up. We just need one earth wire which is connected back to the earth rail on the breadboard. The next stage is to wire up the other end of each reed switch, which are the black wires here, each of which going to a different port on the port expander. There's full details on the website chess.fortherapy.co.uk, which shows the wiring in more detail. Finally, we add in the last two components, the LCD with built-in keyboard and the Pi Zero itself, and this then is the completed system. And you can see the four wires coming from the Pi, which represent the four wires of the I2C interface, which go to the breadboard, and then from the breadboard distributed to the other three components. So that's the complete system. I do hope you enjoy building it and that you go on to build the chessboard. As I said earlier, full details of this project and building an electronic chessboard you can find on the chess site chess.fortherapy.co.uk. Thank you.